Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Vitamath 21. Here is the problem. The centroid of the triangle is defined as the point of intersection of the medians. Prove analytically in two methods that the centroid is given by quantity x sub 1 plus x sub 2 plus x sub 3 over 3, comma, quantity y1 plus y2 plus y3 over 3, where x sub 1 y1, x sub 2 y2, and x sub 3 y3 are the vertices of the triangle. So here we go. So let's have the triangle in general. So call that point 1 x1 y1, point 2 x2 y2, and point 3 x3 y3. And let's locate one median, let us say here, one midpoint rather. So the midpoint coordinates between 2 and 3 is simply the average of the coordinates. So that would be x2 plus x3 over 2, comma, y sub 2 plus y sub 3 over 2. And we will call that midpoint between points 2 and 3 as m, with coordinates 1/2 of quantity x2 x plus x3 over 2 and quantity y2 plus y3 over 2, or simply the average of the coordinates, because this is a straight line and that's the center of that line. So this is the median, the line segment joining P1 and M, and the centroid is here, although it is the point of intersection of the medians, but these 3 points lie on a straight line. So the slope of P1 to C is also the slope of the line joining P1 and M, or P1 and or C and M. So the centroid is at x sub c, y sub c. So slope of CP1 is equal to slope of MC, and we will denote that slope as B over A. Even if the length of the lines are not equal, the slope is constant, and we will just call it B over A in general, or the slope can be reduced to B over A. So slope is the ratio of the vertical distance to horizontal distance, rise over run. So the slope of CP1 is simply y sub c minus y1 over x sub c minus x sub 1, while the slope of MC is quantity y2 plus y3 over 2 minus y sub c over quantity x2 plus x3 over 2 minus x sub c. So y sub c minus y sub 1 over x sub c minus x sub 1 equals y sub 2 plus y sub 3 over 2 minus y sub c all over x sub 2 plus x sub 3 over 2 minus x sub c. And that slope is b over a. So simplifying, y sub c minus y1 over x sub c minus x sub 1 equals y2 plus y3 minus 2 y sub c over 2 over x sub 2 plus x sub 3 minus 2 x sub c over 2. So I'm not showing the denominator 2 because we can cancel the denominator of 2 in the numerator as well as in the denominator. And the ratio is still b over a. Now if we cross multiply or interchange this y2 plus y3 minus 2 y sub c as the denominator here, since the numerator is in general b, then the ratio would now be b over b. Likewise, if x sub c minus x sub 1 is now in this position here in the numerator, and remember that the slope is b over a, then that would now be a over a also, which is 1. So interchanging position, y sub c minus y1 over y sub 2 plus y sub 3 minus 2 y sub c equals b over b, which is equal to 1. Then cross multiply y sub c minus y sub 1 over y sub 2 plus y sub 3 minus 2y sub c equals 1. Then we have y sub c minus y sub 1 equals y sub 2 plus y sub 3 minus 2 y sub c. Then y sub c plus 2y sub c, the additive inverse is 3y sub c. Then put negative y1 to the right, so it becomes positive y1 plus y2 plus y3. Finally, dividing everything by 3, we have showed that y sub c is indeed 1/3 of quantity y1 plus y2 plus y sub 3. So likewise, if we have x sub c minus x sub 1 over x sub 2 plus x sub 3 minus 2 x sub c, that would be a over a, which is again 1. Then x sub c minus x sub 1 equals 1/3 of x sub 1 plus x sub 2 plus x sub 3 with the same process as for y sub c. Now the second method of proving that these are the coordinates of the centroid of a triangle is the fact that the length of the line segment from P1 to the centroid is 2/3 of the length of the median. And I hope that you know that fact. That is, distance from P1 to C is 2/3 the distance from P1 to M. And since the median is a straight line, that ratio or proportion, that distance from P1 to C, or the length of P1C is 2/3 of the length of the median, is also true for the corresponding components, horizontal and vertical components of P1C and P1M. So if the horizontal component of P1C is denoted by delta x P1C, and that is equal to the difference of the horizontal coordinates or x coordinates, x sub c minus x sub 1, and the horizontal distance between P1 and M is delta x P1M. So it means that delta x P1C is 2/3 of delta x P1M, where delta x P1M is x2 plus x3 over 2 minus x sub 1, or simply the difference of the x coordinates. Likewise, for vertical components of distance P1C, that is delta y P1C, and that is equal to y sub c minus y1, upper y minus lower y, and delta P1M is y2 plus y3 over 2 minus y1. So that is, let's have the x component. So delta x P1C is equal to 2/3 of delta x P1M. Delta x P1C is simply the difference of the x coordinates. So right x coordinate minus left x coordinate, x sub c minus x sub 1. And it is 2/3 of x2 plus x3 over 2 minus x1, the horizontal projection of P1M. So cross multiply, 3 times x sub c minus 3x1 equals x2 plus x3 distribute to minus 2x1. Then we have 3x sub c equals 3x1 plus x2 plus x3 minus 2x1. Of course, 3 is x sub 1 minus 2x sub 1 is x sub 1. So we have x1 plus x2 plus x3 in the right side, 3x sub c in the left side. So therefore, x sub c is really 1/3 of quantity x1 plus x2 plus x3. So let's also do that for y. Delta y P1C equals 2/3 of delta y P1M, and we get the same results. Y sub c minus y1 equals 2/3 of quantity y2 plus y3 over 2 minus y1. And since this form is similar to that, then we jump into conclusion that y sub c is really 1/3 of quantity y1 plus y2 plus y3. So that's it, and I hope that you were able to follow the proof, my proof analytically, especially the second one. So if you're new in the first one, then proceed to the second one. That's the best way, the second one. But I'm just proving this in my own way, in my own analysis, that anyway they have the same results. Then for your part, so that you can recall this, the centroid is simply the average of the x coordinates, comma, the average of the y coordinates, but only applicable for triangles. If you have a quadrilateral or an n-sided polygon, then you have to divide the figure into component triangles and apply the Klucik formula for the centroid. Then for the area, let's wait until I'll derive the formula for area by coordinates, and let's apply that in finding the centroid of an n-sided polygon analytically. So for your part, locate the centroid of the triangle with vertices -3, 5, 1, -6, and 5, 4. So you have to apply this formula here and show that the answer is at 1, 1. And another thing is, since the centroid is simply the point of intersection of the medians based from this definition, I want you to find the equation of the medians, two medians, and I hope you can find that equation of a line. That's just equation of a line. You just select two medians from these vertices here, then solve the two equations of the medians simultaneously and verify that the point of intersection, the solution to the system of two linear equations, is really at 1, 1. In fact, you can also find the equation of the third median and any two median combinations. Find the point of intersection by solving the two equations simultaneously and show that it is at 1, 1. So that's it, and I hope that you're convinced that the centroid is really at these formulas here, derived formulas, and I hope that you can apply that in the future when you are confronted with mathematical problems or even engineering problems that need the concept of centroid.